at KPS. In today's video, we will see the complete plastic-to-fuel pyrolysis process, step by step, using real footage from our setup. Let's begin. First, the waste plastic, mainly green and white milk packets, is collected, cleaned, and dried. These plastics are then fed into the pyrolysis reactor. The reactor lid is sealed completely airtight because pyrolysis must occur in an oxygen-free environment. These green and white milk packets are cut into small pieces for uniform heating. Next, the shredded plastic is fed into the pyrolysis reactor. The reactor is then sealed airtight to prevent oxygen entry because pyrolysis happens in an oxygen-free environment. Now the heating begins. The temperature gradually rises from 200 degrees Celsius to around 450 degrees Celsius. As the plastic melts, long polymer chains break down into vapors. These hot vapors travel through the outlet pipe and enter the condenser unit. Inside the condenser, cold water circulates and cools the vapors. Slowly, the vapors convert into liquid fuel, which is collected drop by drop in a container. The process continues until all plastic is converted into fuel, gas, and char. This is how milk packet plastic is turned into high-value fuel using pyrolysis. First, the empty beaker is placed on the weighing scale to record its exact weight. Then the beaker containing the cut pieces of milk packet plastic is placed on the weighing scale. The digital display shows the total weight of the plastic pieces along with the beaker. This measurement is important because it tells us the exact amount of plastic being fed into the pyrolysis reactor. By knowing the input weight, we can evaluate the efficiency of the conversion later by comparing it with the amount of fuel produced. The cut pieces of milk packet plastic are being loaded into the pyrolysis reactor. The plastic pieces are added carefully to ensure an even distribution inside the chamber. Using cut plastic instead of full packets helps in faster melting and uniform heating during the pyrolysis process. After the plastic pieces are loaded inside, the reactor lid is placed firmly over the opening. In this, you can see the operator adjusting and tightening the clamps to ensure the lid is fully sealed. A proper airtight seal is extremely important because pyrolysis must take place in a no-oxygen environment. Once the lid is locked, the reactor is ready for the heating stage to begin. As we know, the reactor is already heated, and plastic is undergoing thermal cracking. The vapors generated inside the chamber move upward and are guided through the outlet pipe. These vapors are the result of polymer chains breaking down into lighter hydrocarbons under high temperature and zero oxygen. This vapor stream will soon enter the condenser for cooling. This shows the burner working steadily under the reactor. A uniform flame is essential for maintaining pyrolysis temperature between 350 degrees Celsius and 450 degrees Celsius. Consistent heating ensures continuous vapor formation and stable fuel output. This controlled heating is what drives the entire pyrolysis process efficiently. Now fully sealed reactor is placed inside the heating chamber. Positioning the reactor correctly inside the chamber ensures uniform heating from all sides. This setup allows the temperature to rise gradually and evenly, which is essential for smooth pyrolysis. Once the reactor is in place, the heating process can begin. Here, we observe the piping system connected to the reactor. As the heated plastic vapor travels, it moves along the metal pipe toward the cooling zone. The pipe must be leak-proof because even a small oxygen entry could disrupt the pyrolysis chemistry. This pipeline forms a bridge between vapor generation and fuel condensation. In this stage, the vapors enter the condenser. The outer jacket of the condenser is cooled by water circulation. As a hot vapor contacts a cool surface, it instantly begins to liquefy. This is where the transformation from vapor to usable liquid fuel actually takes place. The efficiency of this condenser determines the quality and quantity of the fuel. In this, the condensed pyrolysis oil is collected drop by drop. This golden liquid is the final fuel product. The steady dripping indicates smooth vapor flow and efficient condensation. This fuel can later be filtered and used in burners or further refined depending on the application. In this, the final vapors coming from the reactor are passing through the condenser setup. At this late stage of pyrolysis, the vapor flow is low but still contains valuable hydrocarbons. The cooling system ensures that even these remaining vapors are condensed into fuel. This step maximizes efficiency and prevents loss of product. This video shows the fuel flowing steadily out of the condenser outlet. The clear golden appearance of the liquid indicates proper cracking of the plastic molecules. A smooth, uninterrupted flow means the reactor temperature is stable and the condensation process is functioning at peak efficiency. In this phase, the fuel collection container is being filled. You can observe the clarity of the liquid, showing minimal impurities. This is a result of controlled heating and an effective condensation system. At this point, the pyrolysis process is near completion, with most vapors already converted. This is the final stage of the process, where flash testing is carried out on the produced pyrolysis oil. In this clip, a small amount of the fuel is carefully exposed to a controlled flame to observe its ignition behavior. Flash testing helps determine the volatility and safety characteristics of the oil. If the fuel ignites quickly with a small flame, it confirms that the pyrolysis oil has good flammability and can be used as an energy-rich fuel. This test ensures the quality of the final product before it is stored or used. This clip shows the oil obtained from the pyrolysis process. The fuel has a clear golden appearance, indicating proper conversion of the plastic. This liquid is a final product of the entire operation, collected after the vapors have fully condensed. It is now ready for cooling, settling, and filtration before further use. Thank you so much for watching. If you found this video helpful, don't forget to like, share, and subscribe to the channel. Your support really motivates me to bring more content like this. See you in the next video. This is Chemi at KPS.